Welcome to the Explainer. Today, we're tackling one of the notoriously trickiest subjects in the cybersecurity world. But look, we're not going to just sit here reading a textbook. Instead, I want to introduce you to our main character for today's journey, a single tiny packet of data. Let's just say it's carrying a vital fragment of a very funny cat video. We're going to track this little guy as it attempts to cross the wild, hazardous landscape of the internet to safely reach your smartphone screen. By following its journey, you're going to totally master the core concepts of network security.
Okay, let's dive into this. Why dedicate a whole explainer to this one topic? Well, because empirical data actually shows that network security makes up a massive 24% of the ISC2 CC exam. It's huge. And honestly, it's consistently reported as the absolute hardest part for beginners, especially if you don't come from a traditional tech background. It requires a really precise grasp of how data physically and logically moves across a network and exactly where those sneaky vulnerabilities are hiding.
Here's our quick roadmap for today to make sure our cat video packet arrives safely. First, conquering domain 4. Second, OSI versus TCP/IP models. Third, essential ports and protocols. Fourth, firewalls, IDS, and IPS. And finally, number 5, inside the DMZ. All right, let's get into it.
Section 1. Conquering Domain 4. Look, our goal here is to take some highly abstract networking theories and turn them into a tangible, memorable story. To pull that off, we have to follow our cat video packets step by step. You see, whenever data moves from a sender to a receiver, it doesn't just magically fly through the air, right? It has to navigate a really strict set of global rules, knock on the correct digital doors, and pass through some rigorous security checkpoints. If it messes up at any of these stages, the connection drops, your video buffers forever, or worse, malicious data sneaks in alongside it.
Moving on to Section 2, OSI versus TCP/IP models. Now, before our little packet can even pack its bags and travel, it has to follow a specific rulebook. And this brilliantly illustrates the exact difference between the two main frameworks you absolutely have to know. First, the OSI model, the Open Systems Interconnection Model. This is a theoretical 7-layer framework. Think of it like a universal recipe for baking any kind of cake. It tells you, hey, you need a mixing stage, a baking stage, and a frosting stage. But then we have the TCP/IP model, Transmission Control Protocol over Internet Protocol. This one is the practical 4-layer stack that the modern internet actually uses every day. TCP/IP is like the specific practical recipe for a chocolate cake, giving you the actual, real-world ingredients and protocols to get the job done right now. So let's walk our cat video packet through this practical TCP/IP chocolate cake recipe. At the top, the application layer. Your web browser requests the video. Boom. Next, it drops down to the transport layer. This is where protocols like TCP step in and slice that big video file up into smaller, manageable packets. You know, kind of like slicing up a pizza so it actually fits inside the delivery box. Then it drops to the internet layer, which acts literally like a post office. It slaps a logical destination and IP address onto each packet so it actually knows where it's going. Finally, the network access layer grabs all of this and converts it into physical electrical signals or light pulses, just blasting it out onto the cables and Wi-Fi waves.
Which brings us to Section 3, Essential Ports and Protocols.
Okay, so our packet used the IP address to find the correct destination house. Great. But now, it has to find the right door to go through, and that's the port. For the exam, you must remember this. Every open port is a potential entry point for an attacker, so memorize this table. You've got to know the difference between a secure door and a flimsy one. Port 23, Telnet, flimsy, completely unencrypted, just avoid it. Port 22, SSH, now that's your secure encrypted replacement. Now, for our cat video, we want port 443, HTTPS, which is securely encrypted, way better than the plain text port 80. Oh, and definitely keep a close eye on port 53, DNS. That's the internet's phone book, and it is heavily targeted by poisoning attacks.
Next up, Section 4, Firewalls, IDS, and IPS. So our packet is knocking on the correct door, but suddenly, hold up, it gets stopped by the network's security checkpoints. The very first major checkpoint, the firewall. You can think of a firewall as a super strict bouncer at the door enforcing a VIP guest list. It looks at the packet's source, its destination, and the port, and basically decides whether to let it in. A truly, absolutely crucial defensive strategy here is default deny. That means the firewall is configured to block everything by default, explicitly allowing only the specific traffic it's been told is safe. If our cat video packet isn't on that list, it's getting dropped, period.
But let's say our packet does make it past the firewall bouncer. Next, it might get scanned by an IDS, or intrusion detection system. Now, an IDS is a detective control. It's got this massive database of what bad threats look like. It scans our packet just to make sure it's actually a funny cat video and not, say, a malicious worm trying to self-replicate or a virus trying to attach itself to a file. But here's the kicker. An IDS only watches and alerts. It generates passive alarms for the security team, but it doesn't actually block the traffic itself.
And that brings us to the IPS, or Intrusion Prevention System. The IPS is basically the evolution of the IDS. It's placed in line, which means the network traffic literally has to flow right through it. Because of this, an IPS has the power to actively stop a threat right in its tracks. If it spots a Trojan trying to sneak by disguised as our cat video, it doesn't just ring an alarm. No way. It drops the packet entirely, neutralizing the threat before it ever even reaches your device.
Now, what's really interesting about this slide is how it cements this vital exam distinction. If you only remember one thing about network monitoring, let it be this contrast right here. An IDS, it's like a security camera. It's a detective control that sees the burglar and triggers an alarm, but it can't physically stop them. An IPS, on the other hand, is like a trained security guard. It's a preventive control that will actively tackle that intruder to the ground.
Almost there. Section 5. Inside the DMZ.
Our brave little cat video packet has survived the models, it found the right port, and it cleared the firewalls. We're finally ready to guide it to its final destination area. But first, let's pause for a quick practice question to test your Octave learning. In network security, what is the primary purpose of implementing a DMZ, or demilitarized zone? Take a second to think about it.
So the crucial point is that a DMZ acts as a buffer. Think of your network like a medieval castle. The DMZ is essentially the outer courtyard. You put your public-facing servers out there, like your company website or the server hosting our cat video, so the general public can access them safely. But you strictly block access from that public courtyard into the private inner keep, where your sensitive databases and internal employee networks live. If an attacker somehow compromises the web server in the DMZ, that segmentation prevents them from easily pivoting into your highly secure private internal network. Well, we did it. We've successfully followed our data packet from end to end. But before we wrap up this explainer, I want to leave you with one foundational principle from the source material that ties all of this together: the zero trust model. Never trust, always verify. In modern network security, we don't just automatically trust a packet because it's inside our network or behind our firewall. Every single device, user, and packet must be continuously authenticated and authorized. So as you head into your test prep, or honestly, even as you browse the web today, ask yourself this. If you are operating under a true zero trust model right now, would your current network setup actually let you watch this cat video? Keep that mindset, and I promise you'll master Domain 4 in no time.